Alright, so students, for this video onwards, we are going to discuss chapter 2, alright, of our statistic 2. Alright, so chapter 2, we talk about linear combination of random variable. And in this whole chapter, generally, we still need to apply the normal distribution concept and also the Poisson, alright, in doing the calculation part. Alright, so both normal distribution and Poisson are included here. Okay, so because we just completed our Poisson chapter, right, in chapter number 1. So I think for chapter number 2, I will straight away go into the Poisson first when you are still quite fresh with what we have learned in Poisson distribution. All right, to discuss the Poisson part, for this chapter, generally you need to scroll down to the very last part. Okay, the very last part of this chapter. Okay, so you can scroll down. Okay, you scroll down. Okay, until the very last part. Okay, so the very last part, I think it's the end already of this whole chapter. Very last part. Wait. Okay, so it is at 2.4. All right, so the beginning of the part of this chapter, we are going to skip it first because most of them are related to normal distribution. All right, so for me, I will straight away go into Poisson first so that you can link with what you have learned before. Okay, all right, so when you look at the distribution of the sum of the independent Poisson variable, okay, last time when we do all Poisson question, what we did is like you are only having independent, you are only having the variable x in one particular question. Okay, now they are going to combine two different Poisson. Okay, in maybe one question, right? Two different Poisson. So as an example, you might have x is Poisson distributed and y, excuse me, is also Poisson distributed. And then both of them might have different mean. Okay, so when you're having these two different Poisson distribution, how are we going to find out the probability when they want to add these two Poisson variable together? All right, so that means if I say I want to do the calculation for x plus y, so how can I do it? Okay, if your Poisson is x is Poisson, y is also Poisson distributed, then when they want you to calculate the probability for x plus y, okay, it is still remain as Poisson, and what happened to the mean is you just add the mean together. Okay, and at the same time, the variance, it is still the same, right? Variance x plus y means variance x plus variance y, which is equals to m plus n. All right, but for calculation part, we seldom calculate the variance x and y, right? So mostly we are still focused on this part. X plus y is still Poisson distributed with the mean m plus n. Okay, all right. So for Poisson distribution, linear combination of independent Poisson variable of the form ax plus by cannot have a Poisson distribution. Okay, generally for Poisson variable, when they want you to calculate the total, right, they will always ask you to find out x plus y only. They will not ask you to find out the probability for 3x plus 2y. They will not ask you to find out 4x plus y, something like that. No, it is always restricted to x plus y only in our syllabus. Okay, for Poisson part, all right, so you no need to worry about all the other things. So if you look at all these other things appear in your question, all right, generally it belongs to normal distribution, not Poisson. All right, so for our syllabus, Poisson only appear for x plus y, which is Poisson distributed. Okay. All right, so let's have a look for example 22. How are you going to solve all these kind of questions, okay, that is related to Poisson? Okay, you read the question first before we start. Okay, have a look at example 22. Alright, so here they said there's something which has the mean 1.7, right? Okay, then what is it? They are talking about the number of radioactive particles emitted per second. Okay, so here this is a keyword per second. Give you a hint that this question belongs to Poisson distribution. So the radioactive particle permitted by the certain metal with this mean. And after that, there's another object that also emits particle at random with another mean per second. All right, so there are actually two different particles emitted. Okay, so the first one you can say that X is maybe the number of radioactive particle. By what? By particles, by smell, let's say. Okay, and after that, Y is another particles emitted. So maybe the number of particles okay, by what? By another object, okay? All right, so first you need to know that in this question itself, there are two different types of particles emitted by two different things. The first one is emitted by the metal and the other one is by another object. Okay, so when you see that there are two different types, then generally you should label them clearly. Of course, if you didn't write out this in your exam, they won't penalize marks, by the way. Okay, but if let's say for your own understanding, then I think this is good to write it out. Okay, right. Then after you write it out already, you know that X is Poisson distributed and then the mean is 1.7. For the Y, it's Poisson distributed with the mean is 0.6. Right or not? Okay, then now, what the question want you to find is find the probability that the total number, okay, for the next 3 seconds. All right, so there are a few keywords here. The first one is the total number. The other one is the time that they want to calculate is for the next 3 seconds. Okay, so total number means that when you write out the Poisson distribution, it will become X plus Y. Total number means X plus Y, right or not? Then it is still Poisson distributed. Okay, then now you need to write in the mean. So how to calculate the mean? Okay, so just now you're having 1.7 and 0.6, but 1.7 is for 1 second, 0.6 is also for 1 second. Therefore, to change it become 3 seconds, to fulfill 3 seconds in the question, you need to take 1.7 multiply with 3. So you need to change it become the mean for 3 seconds. The same thing happened for the other particle emitted by the other object. So 0.6 times 3. All right, then your mean becomes 6.9. So this is the total number, okay, the X plus Y, the mean for the total number for the next 3 seconds. Okay, and what they want you to calculate is, they want you to calculate the probability of what? The total number is equals to 6, 7, and also 8. All right, so please take note that this is still a Poisson distribution. Therefore, when you want to calculate the probability, you need to use the Poisson formula. So what's the Poisson formula? E negative lambda. All right, so you have to start with 6. So it will be lambda power 6 divided by 6 factorial plus lambda power 7 divided by 7 factorial and also lambda power 8 divided by 8 factorial. And then by just pressing the calculator, you should be able to get the answer. All right, so you can see that it is still a Poisson distribution, just that now you might have two different variables, X and Y, but both of them are still belongs to Poisson. Therefore, when you add them together, combine them together, it is still under Poisson. Okay, so I hope that you can see the difference of the example with what we tried before. Okay, but generally it is still mainly about by a Poisson concept. Yeah, right. Okay, if no problem, then let us continue further. Okay, example 23. So for example 23, during a weekday, okay, there are heavy lorries pass a checkpoint independently at random time. Okay, mean rate from westbound lorry. So you're having westbound lorry is 6 for 30 minutes. Okay, so again, keyword is 30 minutes because this is an interval given in the question. Right, and the mean rate for the eastbound lorries is 3 in any 30-minute period. Find the probability, blah, 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 and so on. Okay, so from this question here, you already can see the difference very clearly. So maybe the westbound lorry, the number of westbound lorries, you denote it by using X. The number of eastbound lorries, you denote it by using Y. All right. Okay, so before you calculate it, originally in this question, eastbound lorry, the mean is 6 for 30 minutes. So you should know that the 6 here is for 30 minutes only. And then for the eastbound lorry, it is Poisson distributed with 3 for 30 minutes. So both are for 30 minutes respectively. Okay, then let's start with calculation for part number 1. They want you to calculate the probability that no lorries pass the checkpoint in a given 10-minute interval. Okay, so here first thing is you see the difference in the interval given for this calculation part. That's the first thing. And the second thing is they are talking about no lorries. So what kind of lorries here? They didn't specify. So that means you have to consider both eastbound and also westbound. All right, so to calculate the probability for both eastbound and westbound, you have to add them together. Okay, so they don't care whether is it from eastbound or westbound as long as there's no lorry pass by the checkpoint. Okay, so you take x plus y, which is Poisson distributed. Okay, for 10 minutes interval, originally you are having 6 for 30 minutes, right? So to change it become 10, you need to take 6 divided by 3. This is for the x. Then plus, okay, for y, originally you are having 3 lorries for every 30 minutes. Therefore, you will change it become 10-minute interval, also 3 divided by 3. Okay, so when you add them together, you will get the value 3 for the mean. Okay, and then for part number 1, they want you to calculate the probability for no lorries. So you can write x plus y equals to 0. Okay, so to get the probability is e negative lambda, lambda power 0 divided by 0 factorial. Then from here you should get 0.0498. Okay, so to me, I don't think it is hard, right? Just that you need to know, okay, there are actually 2 types of lorry here, and therefore you combine them become a single Poisson distribution. Okay, then now let's have a look for part number 2. Exactly 4 lorries pass by the checkpoint in a given 20 minutes interval. Okay, so maybe for part number 2, how can we do it? All right, so again, you still need to change the mean. All right, so it is still Poisson. Okay, now the time taken is 20 minutes interval. Just now 6 is for 30 minutes. So you want to convert it into 20 minutes, what you need to do? Okay, so you take 6 multiply with 2 divided by 3. Okay, and then plus, same thing happens for the 3. 3 multiply with 2 divided by 3. Or you can straight away take this value. This is 3, total value for 3. Okay, for 10 minutes now, right? Therefore, if you want to get mean for 20 minutes, it will be 3 times 2, which is a 6. You will realize that the value is the same actually. Okay, so the mean is a 6 for second example, and you need to calculate the probability for x plus y, which is equals to 4. Again, they don't bother what kind of lorries are there, all right? So you just need to focus on the lorry only, number of lorry only. Okay, so e negative lambda, power 4 divided by 4 factorial, and that's why you should be able to get the answer 0.134. All right, then now we continue to part number 3. All right, so for part number 3, they said at least 1 lorry, okay, from each direction will pass the checkpoint in a 20-minute interval. Okay, so here there are a few important keywords also. First, they are talking about the 20-minute interval. And now, please highlight the word each direction. Okay, so just now, when you calculate part and part 2, they didn't specify which direction, right? They just want to know the total of the number, the total number of lorries. But now they actually they separate it already. They want to know from each direction. That means from eastbound, I want to have at least 1 lorry. From westbound, I also want to have at least 1 lorry. So for this kind of question again, this keyword, when you want to calculate the probability, you should calculate it separately. So that means you are having x, which is Poisson distributed, 6 multiplied with 2 divided by 3. This is for 20 minutes, right? So you should get 4. And then for y also, you need to convert it into 20 minutes interval mean. So 3 times 2 divided by 3, and therefore you get a 2. Okay, so now you need to calculate them separately. First, they want to know at least one lorry. So x greater equals to 1. That means the westbound lorry is more than equals to 1. The eastbound lorry also more than or equals to 1. Okay, so should I multiply or plus for this case? So again, you always see the word independently, right? And another word is each direction. So the complete case is you need to combine both directions. Only is a complete case. Therefore, you need to multiply them. If you cannot accept this, then you just look at the word independently. All right. So it should be multiplied. So x greater than 1 multiply with y greater than 1 for Poisson distribution. I'm not going to show you how to do this. Please figure it out yourself and try to get 0.849. Okay, so again, this question you are still using Poisson and you are using Poisson distribution separately. So have a try and see whether you can successfully get the answer correctly or not. Okay, so this is what you have for example 23. Okay. All right, so if no problem, then let us continue to the next example, example 24. Okay, so in restaurant A, an average of 2.2% tablecloth are stained, same, and independently in restaurant B, 5.8% of tablecloth are stained. So they are having two restaurants here, A and B. So I think it's very straightforward. Okay, then now, random sample of the 5 tablecloths are taken from each restaurant. Use a suitable Poisson approximation to find the probability that total of more than two tablecloths are stained. Okay, so the keyword here is total, and another important keyword that you can see here is approximation. Okay, so when you see the word approximation, that means for this chapter or from the syllabus that you learned before, there are a few, right? Either you can have binomial, you change it become Poisson, all right, or you can use Poisson become normal. These two, right? Because here they already tell you the Poisson approximation, correct or not? Right, so these two are in our syllabus. So which one you think is the correct one? So should be this one. What I know that is binomial to Poisson, it is because of in my question I see this. We have 2.2%, 5.8%. And if I look at the structure of the question, I can see that in total, I'm having 55 tablecloths. And out of this 55 tablecloths, more than 2 tablecloths, something happened. Okay, so from the structure of the question, I know that this origin should be binomial. And I might change it become Poisson later. Okay? Yeah. All right, so how can I complete this question here? Okay, so at first, you know that both of them are actually binomial distributed, right? Then each of them also have 55 tablecloths, and then A is 0.022. And for B, it is still binomial distributed, then 55 and 0.058. Okay, then you double check the condition, okay, for these two examples, for these two variables, sorry. And then you might realize that, okay lah, A and B, both I can change it become Poisson distribution. Okay, so what is the Poisson distribution here? To get the mean, okay, you take 55, multiply with 0.022. Then what do you get? You get 1.21. Okay, wait, my file is auto-saving. And now it is not responding, so I need to wait for a while. Okay, so that means I got 1.21. And then for restaurant B, you take 55, multiply with 0.058, and then you should get 3.19. Okay, so you can see that actually both case here, they fulfill all the condition. Therefore, you only can change become Poisson. Of course, I didn't show it to you how we check it. Alright, so you learn all this in chapter 1. So just go and do some simple revision on this. Okay, so I already convert everything into A and into Poisson already. Then now they are talking about total, right? So when they are talking about total means that you need to take A plus B, which is Poisson distributed for 1.21 and also 3.19. So you add them together. Okay, so when you add them together, if I'm not mistaken, you should get the mean, which is 4.4. All right. Then they want you to calculate the probability of what? More than 2 tablecloths are stained. So that means more than 2 tablecloths means no matter which restaurant it is from, it can be from A, can be from B, as long as the total tablecloth more than 2 are stained. Okay. So again, you have 1 minus probability A plus B smaller equals to 2. Then when you minus, you have to take 1 minus E negative lambda. First term is always a 1. Second term is always 4.4. The third one is 4.4 squared divided by 2. So I will stop at 2 because the number that I want to write here is until 2 minus. Okay, so just press calculator, you should get 0.815. Alright, so this is what we have for our Poisson. The number of tablecloths that are stained from both restaurants. So this is how we do it. Alright, so you can actually convert it into Poisson first, then only you add them together. Okay, alright. So some students, they will do it the other way. That means some students, they will take A plus B first, and then only they should already convert. Also can, the answer is still the same. But I just want to tell you that how to look at it originally. A and B originally as binomial step respectively. So I change them become Poisson first, then only I combine them together. Okay, because at this syllabus we are learning how to combine Poisson together. We are not learning the binomial together, right? Okay, so I will convert it into Poisson first, then only I add them together. Okay. Alright, so this is what I have for part A. Okay, have a look for part number B now. Okay, so for part number B, random sample of n tablecloth. Just now we are having 55 tablecloth. Now we are having only n tablecloth are taken from each restaurant. The probability that at least one tablecloth is stained is greater than 0.99. Find the least possible value of n. Okay, so for this question itself, you do almost the same thing like what we did just now, but the problem now is they didn't give me the number of tablecloth. So I'm having n here. So this one is 0.022. Okay, so we assume that the n is large enough. Therefore, we can combine it become, we can change it become Poisson. And then this one will be 0.022n. Okay, and then for B, also the same thing. It is still binomial distributed with n and also 0.058. So when you change become Poisson, it will become 0.058n. And now, they actually didn't specify the tablecloth is from A or B. Therefore, you just need to combine them together. It is still Poisson distributed with 0.058. You add them together. So 0.022, 0.058, I think you should have 0.08. Okay, n, but I don't know why it's the n. Okay, so to find the n, what they tell you is the probability. So you write out the probability that the number of tablecloth. So number of tablecloth means A plus B, because they didn't specify is it from A or B, right? So the number of tablecloth, at least one. So at least one means more than or equals to 1. And this probability is greater than 0.99. So you write greater. This whole probability is greater than 0.99. So I'm showing you how I translate the sentence into the symbol slowly. All right, so when you look at all the keywords now, you can actually try to write out the symbol slowly. Okay, so this is what we have. Okay, so this is the information that they give me, and I want to find out the n. Okay, so let's start. A plus B greater equals to 1, means that it start from 1, you want to include 1, include 2, include 3, include 4, 5, 6, 7, 8, 9, 10, infinity. So it's very hard for us to calculate it. So the easier way will be, I take 1 minus the probability of A plus B equals to 0. Because more than or equals to 1 means that from 1, you want it until infinity. Why not you just take 1 minus the 0? Okay? So greater than 0.99. So if you rephrase it correctly, you have A plus B equals to 0, which is smaller than 0.01. Okay, so can I get an answer for the n? Okay, no, you can continue and try. When A plus B equals to 0 means E negative lambda, and then lambda power 0 divided by 0 factorial. It is smaller than 0.01. Okay, so again, this value itself is 1. This value also is a 1. I think you tried before, right? Okay, and now you are having E negative 0.08 n is smaller than 0.01. Okay, so now to get the value of n as the power, you need to take ln or you need to take log both sides. So one more time, I will tell you that no matter you are using ln or no matter you are using log, both final answer will be the same. So you no need to worry that if you use log, then how the answer is different. They must be the same. Okay, so if you didn't get the same answer, that means you are doing something wrong. Okay, so both are accepted. So for me, because I'm having the base E here, therefore I prefer to use ln. So I'm having 0.08 ln E. N ln E, right? Ln E here, ln E is a 1. Therefore, I'm having ln 0.01. So to get the n, you move the negative 0.08 over, which you need to change the sign. So I think I highlight this better because a lot of students would ignore it, or maybe they will forget to change the sign. Okay, so if you continue from here, you should be able to get n, which is more than 57.5646, and you write it as n equals to 58. Because in this question, you can see that we are talking about the number of tablecloth, and then the n in binomial distribution originally should be an integer, right? Therefore, the integer which is more than 57.5 will be n equals to 58. Okay, so for all these examples that we discussed here, although it belongs to chapter 2, but generally it is under Poisson. Okay, so I hope that when you look at the question, you know that for this question in chapter 2, they actually combine more than one Poisson together, like put Poisson together. It becomes x plus y, A plus B, and so on. But generally, the concept, the formula, and everything are still the same. All right, okay. So I believe that if let's say some of you already start doing the partial question at the end of Poisson distribution, you might face some problem, some question that you cannot solve, which belongs to this part. So now you learn the video here already. So I hope that you can complete all the questions after the chapter 1, all the partial question after the chapter 1 Poisson distribution. Okay, I believe that there are some part that you don't know, maybe you are not so sure how to solve it before, if let's say you start earlier. Okay, but after you go through with this video, should be no problem already. Okay, I cannot separate out the question in a very detailed way. Okay, for Poisson, therefore I have everything in chapter 1. So after this video, the partial question that you have to try is all the question after chapter 1 Poisson distribution. All the partial question that belongs to chapter 1. Okay, so that's all for this video. Then next video onwards, only we discuss the main thing on the chapter 2, linear combination, and mainly we are using all the normal distribution concept. Okay, so we'll discuss all that in the next video.